Hello. Thank you, and good afternoon, everyone. So today I'll be giving an update on a market study that we did at the Boston Consulting Group. And as the title suggests, at the end I want to motivate a little bit of what it would take for us to get to useful quantum applications. So 3 parts of the session. First, I'll really give a very simple heuristic argument of where we are. Perhaps that's a little bit of a different view from the typical argument that you see. And then the second piece, which is the bulk of the talk, will be about enterprise adoption activity in the last 2 years. And then finally, just motivating on what the next steps need to be for us to get to useful quantum applications. So if we can get to the next one. There we go. Okay, so I saw this chart recently from a famous VC, Steve Jurvetson. It's quite a remarkable chart. It shows you that Moore's law had spanned over 128 years. And on the vertical axis, you can see it spans over 22 orders of magnitude. That is the difference between the width of your hair and the distance to the moon and back. Another thing that's really interesting is you can see that it actually spans over 5 different technological paradigms. So there's got to be something fundamental about this where we are just persistently driven by this exponential law. So an interesting question I'm sure folks at Q2B will ask, well, where does quantum begin? So if we take a very simple heuristic, right, just directionally speaking, if we had 50 qubits, that's 2 to the 50 computational states. If we can operate them at, say, 100 kilohertz to 10 megahertz, and if each quantum computer costs $20 million, we start to land in the range of 10 to the 12, which is 1 trillion to 100 trillion calculations per second per dollar. That is somewhere in the top right corner as I've circled there. So what this is showing is we're really at the precipice where quantum computers are starting to really bridge Moore's law. So we'll stop seeing these exponential curves without axes labels. And potentially that quantum computing in the next 3 to 5 years, when we reach this scale, is really going to show up on a chart like this. So that is tomorrow. What about today? What's been happening in the last 2 years? We looked at the enterprise adoption activity through our survey. And from 2022 to 2024, on a high level, we're seeing about a 50% increase in terms of enterprise POCs. So from about 100 globally to 150. And a lot of it is driven by chemicals and materials simulation use cases in biopharma, in materials, and also in aerospace and automobile. The other emerging trend that's driving more adoption or more POC is that more people are experimenting with hybrid workflows where you would have a component of AI or a component of HPC in an integrated workflow with quantum computing. So, of course, there are some technological providers also experimenting with that, probably in the hopes of coming up with new offerings of their own. If we look at the spend of each enterprise customer, in 2022, we called out an interesting phenomena where it's about a half-half split between companies that were spending less than $1 million to companies that were spending more. And the reason that $1 million mark is interesting is because people who are spending more than $1 million a year are much more likely to be developing internal capabilities, internal IP, as well as having a C-level discussion that regularly happens. Now, if we look at the survey result from this year, that number has gone up by 11 percentage points. So on average, enterprises are spending more on quantum computing POCs as a combination of probably expansion of the scope of the POC and also adding more POCs on a per customer basis. If we look at the breakdown of how people are spending that money, 2 years ago, it was about, again, half-half internal versus external spend. Now, as the spend level increased, we're seeing that the proportion of internal personnel salary has shrunk to about a third. Doesn't mean that people necessarily are spending less dollar amount wise, but more of the spend is moving into vended spend in terms of software and algorithm development, probably driven by two factors. One is, there's definitely an increased focus or realization that for it to be useful, you need to develop software and applications. And the second piece is the quantum technology providers probably have, just significant control over the top tier talent in the market. Therefore, companies really have to vend, to partner and spend that money for their technology providers to help develop software and algorithms. And that also shows up here when we ask people what are the top reasons that companies need to consider to invest in quantum right away. Very consistent with 2022, building capability takes time, and also developing IP are the top two most important factors. But you can see that the scarcity of quantum resources and talent is starting to rise to the top of what drives the urgency for enterprises to invest. Again, this is sort of what we predicted 2 years ago, and it's really happening that end customers are, coming to this realization. But another interesting thing that happened is, as all of the people in this room are probably familiar, in the last 12 to 24 months, the idea of NISQ versus fault tolerance really came into focus. So while a majority of the people we surveyed still believe it's important to invest right away for the reasons that we explained on the previous chart, there is a small portion of folks who are now sort of thinking, okay, we should just wait for full fault tolerance. I will say that, just through our conversations, the definitions of, logical fault tolerance at scale all sort of varies, and there's no consensus. So there's also a feature when you look at this that people may be thinking about different, milestones when they answer this question. Now, we also asked people, what do you think was the biggest mistake that the quantum computing industry made? Very interestingly, there's a block in the middle here that you can see has risen in their weighting, and all of them are about some form of a technological integration, whether it's classical and quantum, whether it's across the quantum stack, or whether it's across different modalities. Now, what this speaks to is that, instead of looking at the primitives and the building blocks, people meaning end customers, are increasingly more interested in end-to-end solutions, right? Where that ultimately is what drives business value. And when asked about what's the most important criteria in a quantum computing vendor, two things show significant change from 2 years ago. One is partnership capabilities, which rose by 19 percentage points. The other one is really industry and business expertise, which rose by more than 20% from 2 years ago. And again, reflecting on the theme of algorithm and software development, what this means is end customers are increasingly looking for quantum technology vendors who can work hand in hand with their domain experts and develop real application algorithms that are useful for their business, and less so in terms of just demonstrating overall, technology speed or benchmarks that are not application specific. A few other takeaways, right, is through the survey, we saw that the majority, right, over 50% of the respondents today say that, it's important, as we've discussed, to invest before technology maturity to build capabilities, build IP. But also, if you look at the last three themes, there's a majority of end customers today who are experimenting with AI plus quantum, majority of the customers who are experimenting with HPC plus quantum, and also majority of the customers who have an active partnership to a quantum computing provider. This is all in the search of, true business quantum usefulness and quantum advantage. So just summarizing the takeaways from the latest enterprise adoption survey that we conducted, there's a 50% increase in terms of enterprise POCs compared to 2 years ago. That's roughly a 20-25% annual increase, which is slightly slower than the 2 years prior, but still, quite high. The majority are experimenting with hybrid use cases. At the 1 million spend mark, there's 11 percentage point increase, meaning on average, each customers are spending more to conduct quantum POCs. A lot of that spend is flowing into algorithm and software development that's done in collaboration with a technology vendor. And finally, partnership capability really raised to the top in terms of most valued criteria in terms of selecting a quantum computing provider. So having seen how the enterprise adoption has evolved in the last 2 years, what lessons can we take from that? What will come next? If we take a step back and take stock of where we are and what we have today, right? We have exponential algorithm primitives. We have, Shor's, we have HHL, phase estimation, various types of quantum simulation. That's been done in the last 10 to 20 years, and that still are the valuable building blocks. We also have hardware that's on the way that some folks might say is already on an exponential path, but ultimately will provide, exponential compute power or computational space that, will happen in the next 3 to 5 years. Putting these two pieces together, what we really need as the next step is what we're calling exponential applications, which are end-to-end applications that are designed and optimized for specific business end use cases that really will have a significant separation. It doesn't have to strictly be exponential, of course, but a significant separation or advantage over classical at the maturity of the quantum technology. Now, why do we specifically call out exponential applications? Is because there's a set of challenges that we're seeing today, which is creating a barrier between the path that people are taking currently, both in software and hardware, to what is ultimately the pot of gold at the end. That is not to say these are unsolvable problems, but just to call out 3 big buckets, right? First one is overhead on quantum resources. You'll have overhead on error correction. You have overhead on state preparation and, the readout precision that requires, especially in a sort of a hybrid iterative workflow. In the middle bucket, there is the efficiency when you want to integrate with classical. For example, data loading, data encoding, and also when you put subroutines together, sometimes the quantum part is exponentially fast, but the classical part is very difficult and slow, and that eats away the advantage. And finally, there's the last piece, which is how does it map to a real applicable business problem? Many advantages today actually require problems that are too large, that's not really relevant to real world business value, or that, there is a clock speed limitation, there is a supply limitation, and there is a dollar cost limitation that, again, as classical continues to improve, really sort of compete with the usefulness of a quantum computer. Again, I want to reemphasize, these are challenges that motivate us to say, what we need are exponential applications and not just the building blocks. And these are problems to be solved, but by no means are these, insurmountable barriers to the usefulness of quantum computing. So, finally, what would that take to really get to exponential applications, overcoming these barriers? It takes co-design, it takes integration, and it takes optimization. And all 3 pieces must be done with respect to a particular specific business challenge that companies actually face. So it takes co-design of both the hardware and the software in collaboration with an end customer domain expert. It most likely will be integrated with the best-in-class classical tools, whether it's C or Gen AI. And then finally, the entire end-to-end workflow needs to be optimized for that business case. And sometimes it can even be as specific as, a catalyst that you're designing the hardware, software, algorithms around. So just want to leave it here to say that we continue to see strong momentum in enterprise adoption. We continue to see great news coming out of providers hitting their milestones, creating the next generation of technology. And there must be deep collaboration with domain experts from customers to really fill the white space of what is really useful from a business standpoint to leverage the technology we're developing. So thank you.
We have a few minutes for questions.
A significant, but one of the smaller wedges on your stack chart was finance applications. Can you talk a little more? Do you know some depth on double-clicking on what those applications are?
So on a high level, there's what we have done is we've grouped together, finance from a investment firm point of view and finance from other sort of financial services in terms of, credit and insurance point of view. So there's the classical, there's the classic optimization problem, things like portfolio optimization that's relevant for trade. There are also other risk, other types of essentially probability sampling problems that are relevant for risk assessment. That's of course important for credit and insurance and so on. And then of course, there's another big bucket, which is machine learning that people are experimenting with for all sorts of things, optimizing logistics and in terms of classification and prediction. But there's more fragmentation in types of use cases that people are doing with machine learning.
Great. Anyone else? Oh. Here, I'll run the mic.
Thank you. I was just wondering what the main access methodology is. Is it via cloud? Is it their own quantum computer? What is it?
Yeah, the main access by far is cloud. It's about 90% through the cloud, 10% through on-prem. And of course, everyone knows the volume of quantum computers being sold is extremely small. So the on-prem are very patchy, right? Like different big national centers, regional centers buying individual quantum computers. But most of the 100 plus POCs are driven by cloud access to hardware.
Maybe one last question? No? Okay. Please, thank you.